Hola chamas y chamos, welcome back to Álvaro Dev Labs. Today I'm really excited because we're gonna combine two of my favorite things. One is doing 3D with ThreeJS, a WebGL renderer that allows you to create easily 3D experience in your web browser, and also Vueuse, the progressive framework from Vue. Not so long time ago, I published a video about using Trois, which is a library on top of Vue to basically a component wrapper for 3JS objects and scenes. But today we're gonna do it in a different way. We're gonna do it bare bone in Vueuse. If you're interested in that video, it's available on the channel and you can check it here. Without further ado, let's get started. Let's get started by creating a Vue app. In this case, you can create it with whatever you want. You can use Vite, you can use Vue CLI, create it from scratch. It's up to you. I can recommend you to use my boilerplate. It's already has every feature that you need. It's called Vitsum. So the way you can install it is npx digit, which is a fancy way of cloning. Alvaro Sabu, Vitsum, 3JS. In this case is the name of the project that we are going to create is 3JS Vue. So I'm going to hit enter. It's already cloned. So I'm going to enter with VS Code. Okay, so here we have the project ready to go. You can check the configuration in the bit.config. It comes with aliases and a lot of cool stuff like CSS for styling, Vue components, auto importing, vid fonts, SVG loaders, internationalization, everything you need. Okay. So the first thing that we might want to do is actually install things, right? So I usually use pnpm. So I'm gonna do pnpm install. Make sure you have shamefully hoist as true, okay? And we install everything.
3 days later.
Now let's install 3JS. So we're gonna do pnpm add 3, and we are gonna add also the types. So types 3. I'm gonna save it like a dependency.
1 week later.
Let's now run the application to see that everything is working as expected. We go here and pnpm run def. So it's gonna open on 4, so I need here to put, okay, and here we have Vitsum. Cool. So what else do we need to do? We will need to clean up the default boilerplate. So if you go to app.vue, you're gonna see that it has a route review. So you probably need to go to index.vue in the pages, and here you have this page basically. Remove everything from the script until here, and also for the div we are going to remove all of this because we are only going to use one page for this tutorial. So I'm gonna also remove the styles, and if we save, we should be ready to go. So to help me explain the following steps, I'm gonna use my slides from GS Canarias that I did a talk there. And we basically need 3 things. We need a scene, which is basically a container of, let me see if I can write here, yes. So it's the container of all the geometries, cameras, lights, etc. that we're gonna use. Then we need to create a camera because the camera is gonna be the projection into the of our 3D scene. So basically how we are seeing the 3D scene, okay? And then we need the renderer, which is going to render everything here, or all the information, all the objects that we create for 3JS into a canvas. Okay, let's get started. So we have our app view or index view here, and we will need to create a scene, right? So the way of doing it is const scene new 3 a scene constructor like this. If you use this notation, you will need to import everything as 3 from 3, okay? The problem with this is that you're actually going to import all the classes and types and stuff. So I prefer to basically do this and import just what I need, okay? So we are going to import a scene. Perfect. Now we need a camera. So const camera equal new perspective camera. So there are two types of cameras. There is the orthographic one and the perspective one. We're going to use a perspective camera, which we are going to import from Tree also. And this constructor accepts several parameters. One is the field of view, which is, well, the explanation here is a little weird. But it's just basically how much can the camera see, right? The aspect ratio, which is going to be the window's inner width divided by the height, okay? And these two parameters, put it as it is right now, okay? So now that we add it, we should add it to the scene. So the way we can add stuff to the scene is by using a scene.add. Okay, if we save, we're gonna see that nothing changed because we actually not rendered yet. Okay, to add the render, we will need an HTML element. In this case, we need a canvas, okay? So right here, we will need to create a new WebGL renderer, which is gonna be our const render, and I'm gonna import from Tree, okay? And then we are gonna set the size of it as it is here, which is the window's inner width and the inner height. So it's gonna say the canvas how much it needs to, and we need to do render. Actually, we need to pass some parameters here. And one of the parameters is basically the canvas. So the canvas is the HTML element where ThreeJS is gonna inject all the scene and stuff. Okay, this is where it's gonna render everything. So by default, the compiler is telling me to use document query selector canvas as canvas element. But we have a fancier way in Vue to use this. We can use template reference. So the way of using this is by putting ref in our HTML element. We're gonna call it experience, okay? And I'm going to create it just right here. It's gonna be experience equal to, yeah, it's gonna be a ref, okay? Imported from Vue. And well, it's gonna be an experience. No, it's gonna be an HTML canvas element actually. Yes. And null, because in the beginning you need to put it as null, so it works as a template ref, okay? And then after it's mounted, it's gonna hold the HTML element from the template, okay? So we no longer need this, we actually need experience value as unknown as HTML canvas. This is just the TypeScript part of it, okay? Because we are forcing the experience value to be the exactly type of element that the web renderer needs. And so we are gonna put anti-alias true, okay? If we save, we should be seeing something right now. So let's see if we have any errors here in the inspection. So we do have one, which is cannot read properties of null. Okay. What is null? Okay. So that's basically because how Vue works. So if you were using a TypeScript or JavaScript application, you don't need to do this because you basically can create the render right away. In this case, we do need to do something. Also, I think we need to do render a scene camera. So what I was saying is that you need to put it inside of the unmounted, okay? So we are gonna use this lifecycle hook of Vue to actually create or render. I'm gonna do this and then put everything here. Okay, that's fine. Let's see what's happening now. Okay, now it's rendering something. We know it because it turned black, right? So if we inspect the element of the DOM, we go here and let's do body, div app. We're gonna see that now our canvas has some properties. It has the data engine, which declares like the application that you're using is ThreeJS, and the version, which is release 144 right now in this tutorial. Also, we're using WebGL 2 and the width and the height. Okay, cool. Now that we know that the rendering is working, let's actually render something, right? So let's create a sphere. Okay, I'm gonna create a sphere. And the sphere is gonna be a mesh. So new mesh, okay? A mesh is basically an object, okay, that is formed by geometry, which is where all the vertices are, all the connections between them, how they create the triangles to be rendered, and the material, which defines like the color or how the light bounces, if it's metallic, if it's matte and stuff. So we need to pass two things, which is the geometry, and we need to pass the material, okay? For the material, I'm gonna use my favorite color for these demos, and what we need to do is just basically add it to the scene. But we don't see anything, right? So how do we solve that? Well, probably it's because by default, everything is in the origin, even the camera. So if we want to see something, we need to put the camera a little bit up. What we're gonna do is just right below the camera, all the objects, the 3D objects has more or less the same properties, and one of them is position. So in position, we can set the X, Y, and zeta positions, okay, and between the axes, and we are gonna just how do you say in English? Get a little bit far from the object, okay? So I'm gonna use 5 here, and now we can see it all, okay? The reason that we didn't see it before is because we actually were inside of the object, okay? Now I want you to see something. If I come here and I resize it, you'll see that the canvas is not resizing, it's still in the same place, okay? We can solve that using Vue. Something that I forgot to add is that the camera also needs the aspect ratio. Right now we don't notice because it's a sphere and it's really simple, but if you don't put the aspect ratio, it's gonna look funny when you resize, okay? So let's prepare that, and in the camera, let's put aspect equal, and it's gonna be window inner width divided by inner height. But you probably notice that we have that in several places, which is window inner here in the aspect of what we actually set in the, yeah, we set in the aspect at the beginning, so maybe we don't need to do it again. Okay, my bad. But we're doing it there, and we also doing it here when we set the size of the render. We're actually using these two. So how can we listen to the resize of the screen and then update our rendering and our camera? If you were doing a vanilla JavaScript or TypeScript application with ThreeJS, you basically will create a window, add event listener, resize, and create your functions to update stuff. But since we are using Vue and we use Vueuse, let's use a composable to deal with that. We're gonna use right here the width and the height of one of my favorite composables, which is use window size. Okay, so this one is one of the ones that comes by default in the core package, and a plane is passing by. I hope you don't hear it. Let's create a computer property called aspect ratio is gonna be computed, because we want it to change every time the width and the height change, right? So let's import this from Vue, okay? And now we can basically remove this and use aspect ratio value. That looks better. Okay, and here instead of window inner width, we can use just width value, and here height value. Following thing is that we are gonna add some watchers to be able to resize and update everything. Okay, update the scene size and the aspect ratio of the camera. So the easiest way is using a watch, okay, from Vue, and we are gonna check for the aspect ratio because we want to know whenever the width of the height changes. So this computer property already have both, and we're gonna call a function, right? But one function are we gonna call here? We want to update the rendering and we want to update the camera. So we need two functions. We are gonna need a function for update renderer and another one for the camera. So update camera. Okay, we're gonna set it like this, and we're gonna create another one for the update camera. So what do we need to put inside of each one? For the renderer, it's pretty simple. We need to add renderer, set size, okay? And we're gonna add again. So the same function here, we're gonna add it here. So renderer, okay? Set size and the width and the height value. And also it's important to set the pixel radio. Okay, which is gonna be the device pixel radio. This is useful if you use different type of devices. It automatically adapts to your device pixel radio. Okay, if you're using a mobile or yeah, you understand. TypeScript is complaining here, or basically JavaScript, because we cannot find the variable render, and that's because we are adding it inside of the unmounted hook. To deal with that is pretty simple. We remove the let here, the const, and we create a let. So right here we are gonna use let, and we are going to call it renderer, and it's gonna be of type web rendering. Let's do the same with the camera because we are gonna have the same issue, okay? And here, instead of using camera, we call it like this, okay? So update rendering, we don't have the issue anymore, that's fine. And for the camera, we also need to change two things. Because in the constructor of the camera, we already set in the aspect ratio, right here. We need to set it again because the width and the height changed. So we're gonna use aspect ratio value, and also we need to update the projection metric. This is a function that you need to update the camera, okay? That's fine, let's save and let's see if it works, okay? So now if I resize, it looks kind of funny because it actually like deform the object whenever we're doing this. And also we're setting this twice, right? So here I'm just gonna call update the render. So the reason why it looks deformed when we resize is that we only render the frame once. So we are not updating the render. Actually, we are setting the size accordingly with the aspect ratio of the window, that for sure, and we are updating the camera. But still, the snapshot is only the first one, so we are not updating that snapshot. And here's where it comes one of the most interesting topics of and gaming in general, which is the loop. Okay, you might have heard about it, and to be able to explain it, I'm gonna use again my slides from the Canarias talk that I did. I don't know how to put it here, but you can see it here. So basically, a game loop, like how video games work, is that they create a photography of each step, so saying in that way, okay, that repeats over time. So normally video games are around 60 frames per second. So that means that in 1 second you are gonna have 60 photographies, okay? You are gonna have to see a car moving, for example, here. You are gonna have a car in the time 0, and then you are updating the position of it. You are moving it in the x-axis, right? So the idea will be you create your initial X where your car is at the beginning, you render it. This is what we are seeing right now with the sphere. We're seeing this frame. But then you're gonna set a function that is gonna repeat itself all the time, that is gonna update the position of the car. So it's gonna add 1 to the X position, and then we render again, okay? That's the primary idea, and that's how it works in ThreeJS. So how do we do that with JavaScript? We're gonna create a loop. So it's gonna be const loop equal to this, okay? And inside of it, we're gonna use request animation frame. So what it's gonna do is like, it's gonna be like a listener. So whenever a frame is passed, it's gonna repeat the function, okay? So we are gonna have for each frame execution of loop, okay? So we are gonna use request animation frame, and we're gonna pass loop. So we add it here, and what we want to do is render again, or is in. So we are gonna do render, and we're gonna pass exactly the same, the scene and the camera, okay? We need to call this bad boy here. So since we are gonna call it right away on the mounted, and it's gonna do the same, we're gonna call it here. So now if we resize, you see that it doesn't deform anymore. It's because the scene is being updated. It's being rendered another time. And we can do cool things here. You remember that the camera, we changed the position, right? We can go to the loop and let's do a sphere. The rotation is not gonna be easy to see because we actually doesn't have lights and stuff. So I'm gonna play with the position. And I'm going to put the Y, I think. Okay. I'm not gonna use a math thing right now. I'm just going to +1 probably. Oh, like this, okay. And you see that it starts animating and going up. So that's because every loop we are updating the position. Something really cool that you can do when using ThreeJS with Vue is actually using composables. But you need to be careful, and I will show you why. I just installed tweakpane. Just follow with me. Tweakpane is just basically a way of debugging the elements in your 3D application. If not, you will need to create like forms or controls outside, buttons and stuff, and then modifying the properties here. But this is really useful whenever you want to play with your scene and change properties inside, okay? So let's take advantage of that, and we are gonna create a composable. So here in Composables, I do have one here, but let's create another one that is gonna use tweakpane. Okay. Why? Because, oh no, it's not a view. It's not a .view. Come on. It's a TS. Okay. So let's go there. I'm gonna copy and paste the code. Okay, you will see it in the link below. Okay. Also, I think I need to add the types because it's not having them there, but it's okay. So we are gonna create it like this, and then in here, before the loop, we are gonna import the FPS graph, okay? Because also a part of the old stuff that they had to control different aspects of your objects, it also can show you how the frames per second is, which is a direct relationship with the performance that your scene is having, okay? So we're gonna use tweakpane. I think we have auto import. If not, how do I call it? Use tweakpane. Okay, now I have it. Perfect. Cool. So use tweakpane and the FPS graph. Okay. And we are going to import also the pane if we want to add something else. Okay. So we need to use FPS graph here, and you call begin, and then after everything, I don't know if after the request animation frame, let me check. No, after rendering the scene. Okay, so here we're gonna end. Okay, let's save it. It's gonna reload, and now you have here in a really nice position the frames per second. So if I change here, something is gonna update. Actually, I forgot to add something, because now imagine that we want to see other objects in our scene, or we want to move around. We can't because we haven't created the controls. But before we continue, some words from our sponsors that made possible this channel. This video is sponsored by Storyblok. Looking for a CMS solution that is great both for marketing teams and developers? Look no further. Storyblok is the headless CMS solutions that you always wanted to have. See how easy it is to change content for your website with a real-time visual editor, creating a delightful customer experience for your teams. Go from a content update to production in no time. Storyblok is easily integrable with multiple tech stacks, making your dev team's life easier. Go and try it for free at storyblok.com. To create the controls, we are going to import them, but you don't import them directly from ThreeJS. That's a weird thing, but it's like optional. So you're gonna find it in these 3 examples: ESM controls, Orbit controls. I know it's a little bit weird, but it works like that. So we're gonna create a control here, which is gonna be of type Orbit controls. Okay, not control. Yeah. Well, yeah, controls. And let's initialize it. So the way you initialize them is here, probably after this, you do controls, and control is gonna be new Orbit controls, and you pass the camera and the renderer DOM element. So basically we're taking the DOM element of the rendering. We could also pass the experience value, but it works better if you pass the renderer right away to do that. Also, we are going to enable damping, okay? Which I don't really know what it does. I have to investigate. Okay, nothing. Well, it's actually doing something. I don't know if you see it. Probably if we change it for a square, it will be easy because the sphere. So let's change it for a cube. Cube here, and I think it's box geometry. I have to import it. Oh yeah, but the box with what? Yes, box has different parameters, so it's gonna be width, height, depth. So 111. Maybe 32 as the width segments. There we have. So you can see that now we are changing this. Okay, we can move it, and we can go up, down, away. Okay, So that's pretty useful whenever you want to go around your scene. I think here we need to use controls update, but it's weird because before it wouldn't work without this, but now it seems like it's not needed. I don't know. I need to investigate. Normally you need to put controls update here in the loop. Now let's get back to the composables topic, because of course if you're using Vue, you will like to have a composition API and you will like to create composables, for example, for the whole rendering process. We can create a composable for that. But you need to be careful because not everything can be reactive. There is a performance reason about that. So for example, if we add the renderer, right? We create the renderer as a ref, for example, instead of a plain object, okay? And maybe we can do it here. Like let's think that this is a ref at the beginning, right? It's a ref null. So we need to put something like ref here, and it's gonna be of type we're rendering, and also it's gonna be probably null. Okay, so imagine that the renderer is like that. So every time we have renderer here, we will need to use value. Okay, so it's gonna be render value. And also we will need to put like if exist, okay, because it's probably undefined. Okay, and where is it? Here, value equal, and if I put this, works. It's possibly no. Okay, let's save it. And right now it's not really noticeable because it's not a heavy application. Okay, but right now we are updating the rendering each time, right? And the problem with that is that if we do a benchmarking between using proxies and using normal objects, proxy is basically the feature below the reactivity in Vue 3, okay? So you can see the amount of operations that object can do against proxies and proxy getters. So that means So that means that you should, for the objects like the render, the camera, all the 3DS objects that are going to be updated every frame, you should use object instead of a proxy, because it's gonna affect your performance real bad. One thing that I really like about using Vue with 3DS though is that if we go to the inspector here, okay, so I'm gonna open the DevTools here, put it like here, and we can open Vue. Okay, and if we go to index, which is the page that we are looking, we can take a look of all the objects because we're using the setup syntax. So we can see like how the camera is in the Vue DevTools, all the things that it has inside, like all the properties, the configuration that we did. And then, for example, the cube, we can see if everything is correct and stuff. So it's really useful for debugging certain stuff that normally if you're using JavaScript, you're not going to be able to do that. So that's one of the reasons I like to use Vue with 3JS. Also, if you need to do any other interface in your scene, it's easier than doing it in JavaScript directly. Okay, you also have the template ref, which is the canvas. You can pretty much debug things here. You can also do it with tweakpane, but it's more useful to do it this way. Then it's up to you whatever you want to create composables with. So I normally, for example, create one for the rendering because there is too much things regarding the rendering. They can be abstracted into another layer in a composable. But just remember not to use ref for the renderer. Just leave it as a plain object, okay? Same for camera and controls. And that's basically it. If you would like to have another video just how to create composables for ThreeJS, let me know in the comments, because it's really useful, especially if you have different pages with different scenes. You can avoid repeating yourself in each one of the pages and components, and you have your composables there. So let me know in the comments if you would like to see that video. And that's how you use ThreeJS with Vue. I hope you liked the video. If you did, please drop a like and subscribe. It means a lot for the support of the channel. Also, if you have any questions, please write them in the description below. Not in the description, in the comment section, you know. All the links will be available on the description, and I hope you have an amazing week. It's Wednesday today, right? Yeah, Thursday. Okay. Weekend. Happy coding.